Okay, from your homework assignment from Friday, which was page 504 to 507. Anyway, these are the last questions of the assignment, and then we're going to continue on to worksheet 15, which are properties of logarithms. If you remember, when you multiply like bases, you add the exponents. Yep. Multiply like bases, add the exponents. This is called the power property for exponents. Power of a power, you're going to apply the power of 3 to everything inside the parentheses, and then evaluate anything. So this would be 8p to the 6 n to the 3rd. I don't know why I wrote that up there so high. But anyway, this one is squaring everything, so this would be 9b to the 6th, c to the 4th. And then when you divide, what do? Subtract. So this would be x to the 3rd, y to the 4th. And anything to the 0 is 1. Okay, so those were the problems that were last in the last assignment. Well, they relate to what we're going to do today. I want to do, okay, so again, I am going to introduce these properties right now, and I'm going to explain them without just having those boxes that have the answers in them or the properties in them. So since x to the n times x to the m, you would add the exponents. There is a logarithmic rule that goes, a logarithm rule that goes along with this exponent rule, because remember, logarithms are exponents. Okay, so if you had the log in, say, I don't know, base b of n, oh, excuse me, my pen's just sticking, times m, you could write it as a two logarithms in a sum, okay, because this is a product and the logarithms are exponents. You could rewrite this as log in base b of n plus the log in base b of m. If you had division, x to the, I'm just making stuff up, guys, so my letters don't mean anything where I'm putting particular letters. You should just be able to follow the rules. You would divide, dividing like bases, you would subtract the exponents. So if you had a log in base b of m, oh, I wrote that goofy. I want to write it differently. I'm just making stuff up, and also I'm doing it here. I did the second hour on the board, but then my person, whoever's might be watching the video, couldn't see it, so I had to do it on here. So this, since it's division, we could rewrite it as subtraction of two logarithms. So this would be log in base b of m minus log in base b of n. And then the power rule, x to the n to the m, that's when you multiply the exponents, m times n or n times m. So if you had a logarithm in base b of m to the nth power, you could rewrite this as, bring that up front, n times the log in base b of m. Because that's an exponent, and so is this. So you multiply the exponents. Okay, so those are the logarithm rules. And then I forgot to leave a couple up there. We did discuss that a log in base b of b would always be 1. The log, oh geez, the log in base b of 1 is always 0. B to what power is 1. And then we had one more that said something like b to the log in base b of x will always equal x. I think there's one more, but anyway, basically we're going to need to know all these log rules, and we added on 3 of them today. All right, so here you go, and this is on your worksheet 15. Properties of logarithms. So again, it's just a repeat of what I just went over. A to the m times a to the n is a to the m plus n. A to the m raised to the nth power is a to the m times n, and a to the m divided by a to the n is a to the m minus n. You subtract. Now we got the logarithm rules. These are the ones I just went over with you. If you have a log and base u of a product, you can write it as the sum of two logarithms in that base. You can separate the u and the v. The quotient, and you're going to need to know that's the product property, and the quotient property, which quotient means to divide. If you have two things being divided in one logarithm, you can separate it into the subtraction of two logarithms. And remember, you can also do the converse of these as well. So you can go from here back to there, okay, and you go from here to there. So you can go forwards or backwards. The power property, log and base b of u to the n is n times the log and base b of u. All right, let's do some problems. So how would we use these properties? Well, I'm going to use the property. This is a power or base, a power property, because that 5 is an exponent and so is this part. So we can rewrite this 5 times the log and base 2 of 4. Okay, and then you would say, well, I know what the log and base 2 of 4 is, because I think in my head 2 to what power is 4, and you get 2. So this is 5 times 2, and so the answer to this question is 10. Pardon? Fun. The sun came out. Yay. All right, now this one we're going to rewrite as, because it's a division, and I'm not saying you couldn't already figure this out. Maybe we already know that 3 to what power would be 1/3 would be -1. Okay, but I'm going to use the rules that we just learned. So we can spread it out into two logarithms, log and base 3 of 1. It's a division, or using the quotient rule, we can rewrite it as minus the log and base 3 of 3. And log and base 3 of 1, 3 to what power is 1 would be 0. And the log and base 3 of 3 would be 3 to what power is 3, and that would be 1. And 0 minus 1 is -1. So it just gives us another way to figure it out. Excuse me. Excuse me. I know that we could do this. Hey, you've already figured out you could do 3 times 9 and get 27, and you could say 3 to what power is 27, you'd write the answer 3. But I want to show it another way using these rules, okay? So I'm going to separate it. Since it's a product, I'm going to write two logarithms, log base 3 of 3 plus the log in base 3 of 9. Log in base 3 of 3 is 1. Plus what power of 3 gives you a 9? That would be 2. 1 plus 2 is 3. You kind of proved it. Bless you. All right, and this one, I don't think there's any other way I would do this one besides doing 4 to what power is 64. That would be 3. Okay. I don't know what I think what they're expecting us to do here, I don't know, maybe break it. I don't know. I thought of something earlier, but I think I'm going to leave that one at that, because that's how I would expect you to do it. Okay, expand the following. Whoa, expand. Now I got some letters in here, variables. All my logs will be in the same base of 2. And then I've got a product in the top, so I'd have log in base 2 of 7. And since this is a product, we're going to write plus, and now I'm going to write log in base 2 of x to the 3rd. And then the next part is divide, so minus the log in base 2 of y. Okay, so I used the product rule and the quotient rule. And now I have one more thing I could have done that you maybe already did notice I didn't do yet. I could use the power rule right here, right? So I'm going to finish it off. Log in base 2 of 7 plus 3 times, I got to bring that exponent out in front, 3 times the log in base 2 of x minus the log in base 2 of y. Now, two things about the next one. I'm going to show this two different ways. We should know that when you have a power on the outside, I could rewrite this 2 times the log of 7/9. But this might come out wrong. And let me explain. Isn't this equivalent to the log of 7 to the 2nd over 9 to the 2nd? Okay. So I want to explain this like this first. All right. So that would be the log of 7 squared minus the log of 9 squared. And then we would use the quotient rule, or the power rule, and put the 2 out front. So it would be 2 log of 7 minus 2 times the log of 9. So what could I do in this beginning of this problem that would help me get the right answer? Now you might see this answer, but is this equivalent? Is that equivalent to it? There's something missing right here, right? What could you do to this, though, to rectify it so it would be equivalent to this one? You can't just divide by 2. The 2's can't go away. Okay, Hannah, say it. Parentheses, yeah. This needs this. All right, so this is a correct form. I'm pointing this out on purpose because I want you to know that you need parentheses there. If you're going to do that, bring that power out front, you're going to have to put parentheses around the rest of your expansion. Because now that would mean to multiply by 2 times the log of 7 and distribute 2 to the log of 9, which would be this. And I'm expecting you to know the difference or be able to recognize these as equivalent properties, but the parentheses would have to be there. So why I'm bringing it up is if you had a multiple choice SAT question or whatever, some test question that was multiple choice, it may be written this way or it may be written that way. Okay, so you need to recognize. All right, moving on. Number 11. I kind of need to write mine down here. So I've got the log in base 3 of 2. That's a product, so I'm going to write plus the log in base 3 of x squared plus the log in base 3 of y. And make sure you're writing them like I am, where you can definitely tell where the base is and that the number's right. These should line up evenly, okay, when you're writing these things. You see what I'm talking about? Just make sure your stuff isn't all over the place, and meaning this would not really be right. This is not the same look as that. Okay. Be careful how you're writing them. You got to be a little bit neat about it. All right. What have I forgotten to do? Or I didn't forget. I just didn't do it yet. The power. Okay. So I don't mean to put this as a division bar, guys. So I'm really going to erase that because it's totally not written correctly at this point. All right. That's the way it should look. All right. Log in base 3 of 2 plus 2 times the log in base 3 of x plus the log in base 3 of y. All right, so that would be your answer. All right, part 3 says to condense. These instructions could also be written right as a single logarithm. That's what you're going to see most of the time, right as a single logarithm. What that means is to condense it, to compact it using your log rules. So I have a sum and a subtraction, and I have a number multiplying. So I'm going to put this back on the 2, and then I'm going to use the rules. If it's addition, we're going to write one logarithm as a multiplication. So this is going to be the log of 6 times 2 to the second. And then the subtraction indicates divide, so divided by 3. And this is like in one big parenthesis. Okay, so we're going to simplify this. 6 times 2 to the second, that would be 6 times 4. 24 divided by 3, this is actually the log of 8. What is the base, since it's not there? 10, base 10, common logarithm, all right? You could actually evaluate this on your calculator. Okay, write as a single logarithm. We're going to condense. We got a sum, so we need to write it as a product of those two logarithms. So we're going to multiply 5x squared and 3. So it's going to be the log of 15x squared. And that I will probably just put in parentheses just to make it clear what I'm showing. The next one, we're going to put the 3 back on as an exponent on the x and the 2 back on as an exponent to the y. So I've got log in base 4 of x to the third minus the log in base 4 of y to the second. And then you could have done this all at once if you're already understanding this well. We want to rewrite it as division. So the log in base 4 of x to the third over y to the second, and then we should put parentheses around that. Okay. Any questions so far? All right. Now we finally show you a change of base formula. Okay. The change of base formula, this is what you need to know right down here. If you have the log in a base, in some base of something, you can rewrite it as the log of the something over the log of the base. It's now in base 10. So you can do the same thing with natural logarithms. That's what this is telling you. You could also do a log, and you could change it to a natural log as long as you did the way it says right here. All right, let's do some examples. So, change of base formula. Evaluate using logarithms and natural logarithms round to the nearest thousandths. This would be the log of 7 divided by the log of 3. Now you go on your calculator and you type log 7. If you do not put a parenthesis in here and you hit divide, you will get it wrong. So you need to close that parenthesis up, and then you can hit divided by, and I forgot what the number was. Log of what? 3. And it won't matter if you close that last parenthesis. 1.77 is your result. And that's approximately because you got to round it. I said thousandth and I only went to the hundredth. I need one more decimal place. What would it be? 1. Okay. So next one I'm going to do log of 147. To parenthesis closed, divided by, I think it was, no, I don't remember. 2, log of 2. I wasn't thinking. 7.1996, we'll round to 7.2. 7 point, if I could open up my key, that would probably be helpful. Don't have to toggle back and forth, but I know you guys could have told me by now. 7.20 with 2 zeros to show you went to the thousandths place. And then I know you guys are capable of type log 50 divided by log 6, and you get 2.183. All right. We can use inverse functions or inverse properties of exponents and logarithms. I think this is the one I didn't write down, was log in base b of b to the x is just x. Because what are you thinking? You're thinking b to what power equals b to the x? So the answer is x. So using these properties, log in the base of b to the exponent that is a log in the same base of x is x. All right, these, since b of x and the log in base b of x are inverse functions, these are true. So using the inverse property of exponents and logarithms, simplify. What would the answer to this be? 3. Okay. Now, if you forget those, you could still figure them out using the properties that we've done prior to this. So this would be 6 to what power is 6 to the third, and your answer would be 3. Okay, this one is 13, and I can explain that another way by saying, well, if I rewrote this exponential function in a logarithmic function, it'd be log in base 5 of something, that would be my something, equals the log in base 5 of 13. Well, what's got to go in that blank is 13. That's why the answer is 13. So this one is just 5. Okay, now we're going to apply the one-to-one property of logarithmic functions that we stated before. If you have the log in the same base on both sides of two things, you can set those equal. Drop the logs and say x must equal y. So in this case, we're going to first have to condense them into one logarithm using the rules we just went over today. And then we'll drop the logs and solve. So here I'm going to put the 2 back on as an exponent, log in base a of x squared. I see a plus, so I know it's multiply times 2 equals the log in base a of 5x plus 3. Next step, I have one logarithm on the left and one on the right, so I'm going to drop my logs, set my x squared. Well, that's 2x squared, actually, so I'm going to rewrite it. 2x squared equals 5x plus 3, and then I'm going to solve this quadratic by setting to 0. So I'm subtracting 5x and 3 from both sides, and then I'm going to factor, if possible. Otherwise, you can use the quadratic formula or completing the square. So this is going to be 2x and x. Oh, I think I need the 3 down there. It needs to be a negative 6x plus 1x to get that negative 5x. Set each factor to 0 and solve. So I get x is negative 1/2 and x is 3. Now I need to check my answers. There's a little notation right there to check. Make sure they're viable solutions and not extraneous. So if I put in negative 1/2 into the original problem, there's a problem right there. You can't take the logarithm of a negative number. Okay? Why is that? Well, there's no exponent that will make a base become negative, and our bases are all positive. Okay, so that means this one's out of there. 3 looks like it's fine. It won't make any of this negative. All right, so we'll try the next one. Condensing, we would need to rewrite this because it says subtract. We have to write it as a quotient, x plus 3 on the top and 2x minus 1 on the bottom. It's like this whole thing's in a big parenthesis, and that equals 2. Well, then I go, wait a minute, this isn't like the last problem. I can't drop logarithms because there's not a logarithm on the right. Write it in exponential form. Yes, Brooke. So the base is 5, the exponent is 2, and that's going to equal our x plus 3 over 2x minus 1. Or you can write this part first. So that's 25 equals x plus 3 over 2x minus 1. What am I going to do now? Kind of spacing this out a little further than I needed to. I could treat it like a proportion and check out the cross products, okay, which would be 50x minus 25, I distributed, equals x plus 3. Then I would need to subtract an x, and I'd have 49x, add 25 and get 28, divide by 49, and then I need to reduce that fraction 28 49ths by dividing by 7, numerator and denominator, and get 4/7. I also need to go and check if my answer is okay. 4/7, that'd be fine, because none of these would become negative. Or they wouldn't give us taking the log of a negative number. Scott? Not going to say that. I could have been more meticulous about checking them, but what I was wanting you to notice is if we get a negative x value, it's not going to work because of right here. So yes, if it will, like if I get a number that's negative here that's bigger than 1, like, or absolute value is bigger than 1, then it's not going to work. Is that what you meant? I hope. You got to double check where the variable is. You can't have a negative base either. Okay, so if you were solving for the base, that wouldn't work either. All right, so let's get this one back into like use our properties of logarithms, quotient property, product property, and power property to rewrite these. So this is a subtraction. I also need to put that exponent back on the 5. So I'm going to have the log in base 2 of 5 to the, x divided by 5 to the 3rd. And then on the right, I'm going to have the log in base 2 of 10 to the 2nd. All right, I can drop my logs because they match. So I have x over 125. I think I'll write in something darker. That looks, the blue really shows up better on that red background. And then 10 to the 2nd is 100. Now you just multiply by 125. And that's 12,500. Okay, for 23, I'm going to put the 2 back on as an exponent. Log in base 4 of x plus 1. Oops, I don't know why I wrote that up there. I thought I was going to divide by something, and I don't need to. X plus 1 quantity squared. So like on this side, if I were to get an x value larger than 11, I would have it. No, so the answer wouldn't work. Okay, so I'll watch out for that. I'm going to drop my logs now, and x plus 1 quantity squared equals 11 minus x. We need to square this properly. It's not x squared plus 1. It's x squared plus 2x plus 1. I caught somebody erased. Sorry. And then we're going to add x to both sides, x squared plus 3x, and subtract 11, so minus 10. Factor x plus 5 and x minus 2 does the job. And we get x is negative 5 and x is 2. Is either one of those not going to work in the original equation? Well, if you substitute negative 5 into the left side, you'd have negative 4, and the log of negative 4 in base 4 does not exist. So the negative at 5 is wiped out. That answer is extraneous. So we've got x is 2. Now, I don't know why I don't have it in my smart here, numbers, but there is a 24 and 25 on your paper, correct? All right, somehow my page got deleted. It says 1/2 log in base 6 of 25 plus the log in base 6 of x equals the log in base 6 of 20. All right, I'm going to rewrite, put the 1/2 back on as an exponent. The log in base 6 of 25 to the 1/2 times x, because that's addition. I use the product rule. And that equals the log in base 6 of 20. Drop the logs. What's 25 to the 1/2 mean? It means the square root. All right, square root of 25 is 5, so I got 5x equals 20, and I get x is 4. And then last but not least, our 25. I'm just going to go ahead and rewrite it as one logarithm. It's the log in base 2 of r times 5 squared equals 0. Now, let's rewrite it and exponentiate it. R times 5 squared, that'd be 25r. And the base is 2, the exponent's 0. 2 to the 0 is 1. So I get r as 1/25. Okay, go back a second here. In the book, it says 2 pages 512 to 513 and gives the problems. Now, I've already made you a worksheet on that you picked up as you came in. It's going to save you time. You should start working on that now. if you did this question of the day, which I could use like as an exit slip or something, which I wasn't planning on doing today, but what would you write as this condensed? Log of a squared. Why did I write that like that? All right, because this would indicate division by whatever's next, and that would be b to the third. Okay, if you were to expand this, it would be the log in base. Well, that's a cruddy color to write on a blue background. Log in base c. What is the exponent on that a? A to the 1/2. Okay, then minus log in base c of b. But I haven't finished because I would need to move. So this would be 1/2 the log in base c of a minus the log in base c of b. All right. Okay, so you've got your assignment here. You've got some time to get started. And then tomorrow we'll be doing the last assignment or whatever newish stuff before our next quiz, which is Thursday. Well, actually in 2 days.